We want to look at ellipses today, and we started talking about ellipses yesterday in terms of just like some general like overview, if you remember. And we said the ellipses were the set of all points where the sum of the distance from the two foci is constant. So if you remember yesterday, we said if you measure the distance from one foci to a point and the other foci to the point, and you add those up, they will always be the same, no matter which point you use. If we would take a point way over here, and we would add those two distances, they add up to the same thing. Now, one of the cool things about ellipses have to do with those two foci. So let me show you what I mean here. So here is a video of an ellipse, okay? And then what's going to happen is pretend that this foci right here is like a light bulb or something sending out a signal. Make sense? And watch what happens. Hopefully you don't have a seizure, it's a little flashy. But everything that leaves that bounces off of the wall. And where do you think it's going to end up? Right at the other foci. So if you have something that is an ellipse, that is enclosed, they all hit there. Okay. Now, here's a video. This is a math number file video, and let me speed this up a little bit. Where they made a pool table that was an ellipse, and the ball is on one foci, and the hole is on the other foci, which should mean what?
It's always go in.
It's always going to go in, no matter where you hit it. Now, when they do this, they do show that if you hit it too hard, it will just like fly over the hole, and so there's a little bit, of stuff that doesn't make it work perfectly. But let's watch here a second. Right here, he's explaining how you hit it too soft, it goes a little to the left. Too hard, it goes a little to the right. So there's a little bit of hitting the sweet spot in terms of the right. Can't put spin on it and all that kind of stuff. But if you hit it, they'll go in the circle. So there's another good video here in a second. They show you for like a whole bunch of pictures at the same time. There we go. Here's a stream where you can see they hit it all different ways, and all of them bounce directly to the other foci. So there is an example of ellipses. Okay. There's actually a three-dimensional version of this, other than a pool table. If you've ever been to the U.S. Capitol building, the rotunda. There's like what they call a whispering room. And what that means is the room is elliptical shaped and the roof is elliptical shaped, right? Like a three-dimensional version, if you can picture that. And if it's called a whispering room, because if you stand at one foci and you whisper, they can hear you at the other foci. Because all of the sound that leaves your mouth all gets bounced where? Directly to the other foci. So even if there's people in the middle that won't hear you, the person over there will, because all the sound gets bounced to that exact same point. Those are like some. Now, I'm not sure how much this can be necessarily really useful in real-world applications, unless you're trying to build a listening room so you can whisper back and forth or something. But that is the properties of an ellipse. All right, so let's look at our equations of an ellipse. So we have two types of equations for an ellipse. We have the one on the left, x minus h squared over a squared. plus y minus k squared over b squared equals 1. Or the second one over there, b squared is under the x and a squared is under the y. Write those down here. And the question becomes, how do you know which one you're on? So if you look at an example here, how do you know which one's the a squared and the b squared? Well, that's this right here. A squared is always the bigger. A squared is always the bigger of the two numbers. Okay? So I'll talk about C in a second here. Now, we're going to just jump. We're not going to stay today on just having our center at 0, 0 like we did in parabolas and break it into multiple days. We're going right into our centers not at 0, 0 because I think you've already done this before. Our center here is going to be at what? From what you've done with parabolas for vertexes, with circles, our center is just at HK. So here our center is at HK. Now, our direction, and I don't know how you want to write this. I think of it as left and right, up and down, and here's what I mean by that. If the A is underneath the X, this opens, this is like longer like that. Call that left or right. If the A is underneath the Y, it opens like that, up or down. That kind of opens. Now, in some ways, you don't even have to worry about that. It's going to be obvious once we do this. You'll see what I'm saying. Okay. All right. So let's do an example and kind of look at everything and then show where they come from. Or do you just want me to write down the formulas and have no idea what it means? What do you prefer? Okay. I don't use the formulas when I do it, so let's not use the formulas and we'll come back to this. So let's look at this example. First off, where's the center? 1, 2. Okay, so 1, 2. Now, for a second here, if I said graph a circle with the center at 1, 2, with a radius of 2, what you would do, and this is not this problem, but just to understand, is you would go 2, 2, 2, 2, I want 3 there. You would do that, right? There's your circle. That's how you graph a circle. So an ellipse is very similar to a circle. So first off, from what we've talked about already, what is our A here? 25 is A squared, so A is just 5, and B is 3. Now, what I'm going to do is the number underneath the X is my A, 25, which is 5. So in my X direction, I'm going to go 5 each way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. In the Y direction, I'm going to go how many? 3. 1, 2, 3. 1, 2, 3. And now I'm going to connect those dots as best I can. And there is my ellipse. So do you see how, when we talked about that open part, did we really have to consider which way it opened? It just happened automatically. Whatever's underneath the X, you go left and right. Whatever's underneath the Y, you go up or down. Now, once we have our graph, I'll say mathematical term, which way is the long term? Which way is the long way? From here to here or from here to here? This way is the longer one, right? That means these 2 points here are known as my vertices. Now, how do I find those vertices? I went from the center, and I went left and right, how far? Which is my what? A. So my vertices are 1 plus or minus 5, 2, which would be 1 plus 5, 2, which is 6, 1 minus 5, which is negative 4. Now, if I go back to my formulas, my vertices here are going to be H plus or minus K. Your vertices are always the long way. So what if your A is underneath your Y, and your long one is up and down? Now you're going to add A not to H, but to K. So over here, my vertices are there. And the last thing we need is our foci. Now, to find our foci, we're going to need to find C. There is how we find C. What's wrong with that? It's like a messed up Pythagorean theorem because it has a negative in there, right? It's like A squared minus B squared is C squared. The way to kind of remember that, we're going to eventually look at hyperbolas. And the difference with hyperbolas is there's going to be a minus here, and there'll be a plus there. We'll get to those later. Okay? So we need to find C because our foci is H plus or minus CK, or HK plus or minus. So one of the first things you're going to do is you're going to graph. You're going to find your A, you're going to find your B. It kind of goes back to when you were doing quadratic formula, right? And you first learned how to do it. You'd write down what A equals, what B equals, what C equals. That's what we're going to do here. So we found A and B. Now we need to find what's C. And C squared is A squared minus B squared. So C is 4. So that means our foci are 1 plus or minus 4, 2. And notice where they're out in the graph. I'm now going to go 4. 1's going to be there. 1, 2, 3, 4. 1's going to be there. So we have these formulas, but really it's about, okay, going to the center, looking what's under the x, looking what's under the y, you move this way, you move that way to get your answer. All right, let's try another one. Same one. That one? All right. So, first off, where is the center?
1, 0.
Positive 1?
Negative 1, 0.
Negative 1, 0.
Thank you.
So, see it better. First thing I want you to find is what is your A, what is your B, what is your C? Think about those first. From what we just did, what's your A? So what's our A? 6. B, C, square root of 20. Okay, now, when we do this, what's the square root of 20 equal to? Without a calculator, tell me what the square root of 20 is. You're smart people. Some of you.
4.4.
Okay. Is it bigger than 4?
Yeah.
Yeah. Less than 5?
Yeah.
Yeah. So, think about this. If I told you to put a dot on this graph at 4.3 or 4.7, what would be the difference? That would be about 4.3, right? Maybe 4.7 is about right there. So if we know the square root of 20 is a 4 something something, we can get pretty close to where it should be, right? If you want to put it in your calculator to figure out exactly what it is, I don't know exactly what it is, but that's going to get us close enough to kind of at least get us in the right area when we do it. Okay. All right. Now, vertices. To start off, we want to graph it. Here is our center. How far do I go left and right? 4. 4. 1, 2, 4. 1, 2, 3, 4. How far do I go up and down? 6. 6. 1, 2, 3, 4, 6. 1, 2, 6. Draw the graph. I'm going to be looking for those 4 points. I'm not going to be looking at how good you draw the ellipse, because obviously look at mine, it looks horrible. So I'm going to judge. Maybe yours looks better, maybe yours looks worse. But I'm not going to worry too much if it doesn't look. I'm going to look for those 4 points. Now, our C, we said, is a 4 something, right? So from here I go up 4, 1, 2, 3, 4, and a little bit. So right about there is my foci. 1, 2, 3, 4. Right about there. Square root of 20 is about 4.5 roughly, right? So close enough we can get to these. So now let's write down our vertices and our foci. Our vertices are -1, 0, plus or minus 6. Notice because we go up and down, we're now adding to our y-coordinate. Our foci is -1, 0, plus or minus square root of 20. Now, one thing I want to talk about here between these two, that we've kind of talked about, is this idea. I said the long and the short. The technical term here is the major and minor axis. Since it's not on your nose, that there's some spot at the bottom of your front page where there's some blank here. So when you have an ellipse, our major axis is the longer of the axis across the ellipse. The minor axis is the short one. So how we will use this is as we go further, we'll know certain pieces of information about these. They'll give you something and ask you to find the equation, and then this is how we're able to do that with the major and minor axis. An ellipse is a lot like a circle. What I mean by that is when you look at the graph, is the center on the ellipse? It's not actually on the ellipse, is it? Just like a circle, is the center on the circle? No, but you need the center to graph it, just like we need the center to graph it. Now, we said A is always bigger than B. What would happen if they were exactly the same? First off, where's my center here? 0, 0. And what's my A? 2. By B? 2. So they're the same. But what would your C be then? 0. So what is this? Can't be a parabola because they're both square. It's just a circle. So if you have something like this, your 0, 0 is your center. You go up 2, left 2, down 2, right 2. And your two foci, you add and subtract C, but C is 0, is basically at the center. So really, a circle is just a special, or a circle is just a special case of an ellipse that works the same way. So, what happens if we have that? Look at it over back to the front. Some of you are already on the front. Notice our two forms of our equations. When we work with ellipses, they are always, 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 always equal to 1. This one is not. So we got to put it in the right form so we can do everything we talked about today. What do I have to do to make that equal to 1? And what you want to look at is over here. What do I have to divide that by to make it equal to 1? 36. And now over here, I divide by 36, and I will get this. I want you to do that one. Graph it, find the center, find the vertex, find the focus. I don't usually write down the direction that much. That's helpful here. See if you can figure this one out using your formulas. Who wants to? Anyone want to come do it?
Sure.
Go for it.
Yes, you.
Go for it, Ian.
I mean, I'm pretty sure as well.
Do you guys have confidence in Ian?
Yeah, I usually have good confidence in you for the
Good luck, Ian.
I'm gonna write A.
Yeah, write it all over there. You can check their work, see if they did it right.
Thanks, man.
Pretty even, right?
It's tricky being able to write on the board like neatly, and
Don't screw up.
it takes. It's hard because so many times when you write, you put your hand, or you're used to putting your hand on it, and you write on the board, especially the smart board. It's just like you can't touch it. So it takes a knack to get used to and do it neatly enough that people can read it. Some of you are not very neat.
Oh, not at all. Oh, this is gonna be a struggle here.
This is the hard part.
Yeah.
This is the hardest part of the whole thing. Drawing that line so it doesn't look awful, or they can miss the dot.
Hey, don't be afraid.
Hey, it's all right.
Miss the dot.
Absolutely, yeah.
Nice spot, Ian.
You want to move it, slide it up? Does it help you to?
Maybe.
set it
Oh,
up?
yeah, that's so much better.
Why you-
Because I need to just a little bit.
Perfect.
Exactly what I got.
What's the score in 5?
Something in between two.
2.2 something.
2.23 something. Yeah, why do you have that? Markers? Yeah.
He
I
puts
just don't pay attention.
them down for
It
you.
doesn't bother me, so I just throw them out.
It bothers me.
All right, that looks good. Do we agree with Ian?
Yes.
Looks pretty good.
Let's go.
Switch. Think about whatever's underneath X, you go X that far left and right. In this case, 2. Whatever's underneath the Y, you go up or down.
Let's go.
Next direction, you just want to kind of like.
I'm not, honestly, I'm not too worried about the direction. I mean, on your homework, I say, find the vertices, the foci, and graph.
Okay.
I'm not really worried too much about the direction.
I missed the dot on the bottom one on my paper too.
Me too, Ian.
Now, let's try that one. You have a little bit of space at the bottom there. Let's say if I give you that.
What?
Find the equation of ellipse has a foci and has the length of the major axis as 10. So, first thought. Draw a picture. Draw a picture.
Now.
So, rough sketch, where the foci are at, the length of the major axis. So,
Oh, it's supposed to go this way.
well, you'll be able to tell once you put down the 2 the points, right? So, right. Yep.
God bless you.
Thank you. So we get that much. Now, first off, based on this up here, where is our center?
Probably about like 0, 2, 1, 2.
1, 2.
And
Then it goes 1 to right.
Because it's going to be where between these two,
oh yeah, right now.
right in the
Middle.
center. Right? So it's going to be right there is our center. I didn't draw it perfectly to scale here. Now, from this and from the information we have, do we know what A is?
4.
Length of the major axis is 10. So that means the length of the major axis is 10. So what is A?
5.
And A is 5. The length of the major axis from here to here is 10. So A is just
Oh, it's half of 10. So
half of that, which is 5.
Yeah, I got it.
So what's my C?
My C.
Oh, just.
Right over the foci, right over the foci are at. So it is 4. How do I find my B?
Square both of them and
I know C squared, A squared minus B squared.
B is
This
3.
is 16, 25 minus B squared. What's B? 3. 3. B squared is 9. B is 3. Now, we know B, we know A, we know our center. Write down the formula.
I got you.
Right down.
You should let me in that formula.
Now, if you know this is an ellipse, look what I just wrote down right there. That has absolutely no information from this problem at all, right? So even if you have no clue what you're doing, you can make it look pretty good with having no idea what's going on, right? Because if you know it's an ellipse, you get to that, I'm going to give you like half credit or a little bit, you know, I mean, just for getting there, right? You're in the right ballpark, having no idea what's going on. Now, with our center, we get to there, we get to there. Now, we know our A is 5, but is it under the X or is it under the Y?
Here's both.
Well, how do we know, like,
wait, it's cool.
That's the question.
It's because like, well,
The foci are over here.
So if the foci are here, then A has to go with the foci, right?
Yeah.
And so that tells me that my vertices are gonna be out here,
Yeah.
which 25 has to be here, that push.
So it's the same problem as the one on the front.
It is the same. Yeah, it is the same. Probably this one.
You just worded it.
You just got work.
All right. We're gonna stop there, for today. Where we have to come back next week is what happens if it looks like that.
oh, that's stuff.
So, well, this is what we did yesterday with the parabola, but now we have an x squared and a y squared, so we're gonna have to complete the square with both of them to get it into this form, so we can find our center and vertices and all that kind of stuff.
I like this. This is fun.
Yeah.
You like these better than parabolas?
Yes.
That's what we've already done parabolas. We've already talked about the HK and all that kind of stuff. So the plan is to do this, just to give you a heads up the rest of the way, this next Monday, we're gonna review and try to take a quiz over parabolas and ellipses before we go for
Well, I should get about 50% on it.
Thanksgiving. And remember,
I'm good with my lip.
remember, you're allowed to use an index card
On the quiz?
on the quiz. Any formulas you wanna write down on the index card about ellipses and parabolas, you can write anything you want down.
I'm gonna write which is taller, the Statue of Liberty or Washington.
I can guarantee you 100% that will not be on the quiz.
Mine was the Eiffel Tower.
Oh, it was different on A and B.
Different forms had different, some had Washington Monument and
And
Statue of
Statue of
Liberty, some had the Eiffel Tower, so.